Welcome back. Remote Learning 2. This is the second week. We're going to look at some of the numbers around the COVID-19 pandemic and connect to some of the things we're hearing about nearly constantly in the news. The goal today, sort of three sections. We'll talk about the mortality rate. In particular, how do you figure that out? And what are the pros and cons of that? Or what do the numbers mean? The incubation period. So that means if you're exposed to it, someone sneezes in your face, how long before you should expect to present any symptoms, and what does that mean for being contagious? And then that will kind of connect in to the last bullet item, which will be checking on exponential growth. Last time we talked about exponential growth, made some predictions. We'll check in on those, see how they're doing. Recognizing that I made the slides a couple days ago before I recorded this, and so everything's out of sync. And I'm recording this on Sunday, the day before you would see it for the first time, Sunday the 29th. And we're talking about what does it mean to grow exponentially? It can't grow exponentially forever. What happens when it doesn't? And how does that connect to flattening the curve? And how do all the things we've talked about, how do they do that mathematically? All right. Mortality rates. So mortality rate is tricky. I remember being younger and thinking mortality rate meant the likelihood that you would remain alive. To be mortal means to be alive, but I guess it's always confused me. That might just be me. But anyway, mortality rate, if you're not familiar, is the rate at which people die of something. And the mortality rate for everyone of every age and every physical condition is non-zero. We already know that. With epidemics and pandemics like this, knowing the mortality rate for something like this is really important because it affects our response. And it's also very hard to figure out the mortality rate for a new disease for a lot of reasons we'll talk about in this first video. So this is a screenshot from the Worldometer coronavirus website. So you see that when I first made this slide on the 25th, there were a little less than 500,000 cases, 21,000 deaths, and 100,000 some odd people had recovered. This is aggregate data. It's useful because we get a picture of the world, what's happening in the world. However, this includes all possible age groups, all possible pre-existing conditions, socioeconomic backgrounds, geographic differences, all countries, and it's time-lagged as well. So how do we use this to find a mortality rate? The way that's usually being reported right now is to take the total number of deaths by the total number of cases, which would give you, from this screenshot, it's changed a little bit, 4.5%. So again, that's an aggregate number. It includes all the deaths and all the cases. And you could also calculate recovery. And the recovery number should make you suspicious. Wait a minute. If 4.5% die and 24% recover, what happens to everybody else? Yeah. So the recovery number, which nobody's reporting, of course, because it's a silly percent, kind of tells us why the mortality rate, when calculated in this fashion, is also a little silly. So the reason they do it this way is that at some point, when the epidemic is all done, that is how you calculate the mortality rate. You take the number of deaths divided by all the cases that have been recorded, and you divide them. And that tells you, what percentage of people who were infected passed away from it. We can't do that now because we're in the middle of an epidemic, but we're also trying to figure out, how alarmed we should be. Another problem with this is that cases, and this is probably clear to a bunch of you, this number, if we go back, this number includes cases that have been recovered, finished. It includes cases that have resulted in death, but these two numbers don't add up to 500,000 people. This number includes people that were diagnosed yesterday, half hour ago, 3 days ago, a week ago. And so it's not clear what's going to happen to quite a few of these people. Some of these people who were diagnosed just a day ago may be fine. Some of these people are in critical condition, but they're not recovered and they're not dead yet. So what's going to happen to them? So there's different time scales in this number. That's another problem. So if you scroll down worldometer/coronavirus a bit more, they give active cases. How many? Again, this is whatever 5 days old by the time you view it. How many cases are active, currently infected, mild condition, serious condition? Then how many cases are done? To be done, you're either recovered or you're deceased. This is a bit more sobering. All right. Where was I? I had to move. Kids came home. So, where was it? We're chatting about. Right. So, this is the percentage of cases that after these cases have finished, this is what's happened. So, is this the mortality rate? Well, it's really still too early to know. As I'm sure you're aware, reading the news, many countries, many municipalities have been slow to act. That means that things get out of hand quite quickly, and that causes more deaths. If you overwhelm medical establishments and they don't have enough equipment or enough personal protective equipment or enough tests or all these sorts of things, it exacerbates the problem. So the sort of interesting thing and unfortunate thing about these numbers is these aren't a measure of a best case scenario. That is, what percentage of people in good health with plenty of access to doctors and medical equipment, what percentage of people would actually fall ill? It's complicated. It depends on where you are and when you are and what kind of responses your municipality or state or government has taken. So let's see. But it is something to keep in mind, recognizing that. Well, let's keep going. All right. So here are two different numbers. Now I want to reiterate, and this has been a theme of Math 101, that simple math can still be complicated. We're just using division here in percent. Which number is a better gauge of the seriousness of this virus? There isn't. There's a variety of competing ways to estimate this. We're told all along in our math classes that math is black and white. There's a right answer and a wrong answer. And to some degree, that's true if we're talking about 1 plus 3. Yes, 4 is the answer. But applying mathematics to the world, well, which application do you use? Which operation? That is by no means black or white. That is by no means right or wrong. There are competing ways to apply mathematics. And simple ways, just calculating percents, just trying to figure out how serious this is not necessarily a simple matter. So talked about that, and let's add one more nuance to this, right? The disease is all over the world at different stages, and we'll look at a video with a visualization towards the end of this lesson. Again, these numbers are aggregates. They represent all cases. So we can look at two particular cases, two countries that have dealt with coronavirus. Italy is still dealing with it. And this process is called disaggregating the data. That is, if we were to look at all of the countries, and you can do this on Worldometer, it has a nice table where it has all the countries. You can rank them by total cases, total deaths, new cases. If you look at these two, and I picked these on purpose because Italy is buried, although at the time of this video, the United States has surpassed Italy in total cases, but not total deaths. But Italy is a mess. The mortality rate in Italy, just doing this simple division here, is 10.5%, while it's 1.5% in South Korea. This is almost a factor of 10 difference. And it's being attributed to the response of South Korea. South Korea is extremely aggressive with testing and quarantining, and Italy wasn't, and that is likely the difference between these two situations. So, what is the mortality rate of this novel coronavirus? We don't know. It's all over the place, depending on what the countries are doing. It's fairly sobering. It depends on what we do as a group of people. Okay, practice time.